Hello friends and welcome to my channel. In this video I'm going to talk about the use of rear diffuser in a performance car. So let's crack it. Rear diffusers are an aerodynamic aid that is connected in the rear overhang of a performance car. Rear diffuser will be always connected to Venturi tunnel. The working principle of a Venturi tunnel is the Bernoulli's theorem, which states that P plus half rho V square is equal to C, where P is the pressure, rho is the air density, V is the velocity, and C, which means it's a constant. So as the pressure increases, the velocity will reduce. If we need lower pressure, we need to increase the velocity of the fluid that is flowing through. Venturi tunnel have a gradually decreasing cross-sectional area that the air flowing through it will have higher velocity, and the Venturi tunnel is situated in the underbody of the car, which means it can make a lower pressure region underneath. The prime objective of a road vehicle is to provide more traction. For more traction, we need more downforce or negative lift. It is the effect of pressure difference between the top and bottom of a car. So for producing negative lift, we need higher pressure above the vehicle and lower pressure below. This relative pressure difference will cause a net force that is acting in the downward direction of the vehicle, will help the car to stick to the ground more effectively, which means the car can transmit the tractive forces effectively to the road. So we have more downforce, so our car will be more agile and stiff during corners, and we will have better track performance with a Venturi tunnel. If we release this higher velocity air directly to the aft of the car, we will have a lower pressure region in the aft side, so the net force developed due to the pressure difference between the fore and aft of the vehicle. We know the airflow around the vehicle will create a high pressure region in the front of the vehicle, and the high velocity air that is leaving to the underbody of the car will create a low pressure region in the rear side, so the net force will be acting in a direction opposite to the vehicle motion, creating to more aerodynamic resistance or aerodynamic drag. So we have to reduce the velocity of air that is leaving the Venturi tunnel. That is why we are using a diffuser. A diffuser that is connected to the end of the Venturi tunnel have a gradually increasing cross-sectional area, so it can reduce the velocity of the air flowing, so it will contribute to an increase in pressure or air pressure that is leaving the Venturi tunnel, and it have a design to direct the airflow to the top of the car, where the air that is flowing over the vehicle will meet the underbody air in a point that is very much close to the rear side of the car, which means we can reduce the absence of air in the aft side, so the net force that is opposing the motion of the vehicle will get reduced, and we can produce more aerodynamic efficiency by using or equipping a diffuser. An effectively designed rear diffuser can also increase the downforce by creating a vertical downward force that helps to stick the car to the ground for producing more downforce and better traction to the wheels. If there is no rear diffuser is used in a performance car, we will have higher aerodynamic drag by using the Venturi tunnel effect. Let's summarize the effect of a rear diffuser. It can increase the downforce or negative lift by providing a lower pressure region in the underbody of the car. It can also increase the pressure of the air that is leaving the Venturi tunnel, and it can direct the air to the top by reducing wake effect by increasing the pressure in the rear side of the vehicle, which will reduce the overall net force and reduce the air resistance that is faced by a vehicle during motion. If you learned about the use of rear diffuser in a performance car, please leave a thumbs up and support me by subscribing to my channel and hit the bell icon to get notified when I make a new upload. Thank you for watching. Have a nice day and bye.